Okay, let us stop there and actually go back to the whole notion of really just the design of the building relative to daylighting, shadow, and reflection, and kind of think about where we left things last time. So what I'm going to do is actually go back and open up, since you guys can't follow along, sadly. Still dead on the system, correct?
Yeah.
No worries. I'm surprised no one like has. Yeah, I'm surprised no one's fixed that yet.
He asked me to do a couple of things. Still not working. Mark.
Well, he asked you what?
He asked me to do a couple of things, but it's still not working.
Okay, no worries.
Waiting for
We'll take a look at that afterwards. Okay, where we left off last time was this whole notion of thinking about, it's really windows and curtain walls and thinking about windows and fins and shelves and things like that and trying to understand the behavior. So let me ask you this, because that's where we left you last time. Relative to the whole notion of fins and shelves and things like that, as you went wandering around looking at different buildings on campus, have you figured out any sort of pattern to these? Because actually typically is a really big pattern, a really big determiner. Yeah. So when do we tend to have shelves? When do we tend to have fins, like vertical fins, as opposed to horizontal shelves? Any sort of general notions?
Shelves around the south-facing wall.
Yeah, that's generally the rule in terms of how things work, and it really has an awful lot to do with just how the sun comes and how the sun reflects off on really what we're trying to do. And let's see if we can sort of actually even construct an example that'll sort of make more sense to you. So what I can do is actually take this building, and let's just actually stop to think about it in terms of what's going on. We'll look at it in a couple different places. I have this place over here where I have a fin. I have this place over here where I don't have a fin. Let's now stop and think about it. Because you can start to see the behavior a little bit just by looking at the shadows that are cast into the building and trying to understand as those shadows are cast into the building. Oh, just really what is and isn't impactful. So I'm trying to think, where did I leave this building? I left this building in December where the sun is relatively low in the sky. Okay, where did I leave it in terms of time? About 4 in the afternoon. That's pretty late in the afternoon. Then we're going to back that off a little bit. See if I can get that backed off a little bit. Come on, you. Absorb. Take it. Shh. You hate it when software fights with you. Let's see if we can make it work. Oh, it's over there. Let's take a look at this. And to understand our little building here a little bit better, let me do this. Let me put the section box on, because that'll actually help us see inside what's going on just a little bit better. I got my section box there. Let me just kind of slide this back and see if we can sort of slice into that building. Maybe we can orbit it around a little bit. Okay, so we can start to see the shadows that are cast in the building. This is our wintertime scenario. Notice it's happening in the wintertime. In the wintertime, let me zoom on in there so you can sort of see it a little bit better. At 1 o'clock in the afternoon, okay, what tends to be happening is like all the sunshine, which is actually probably helping us warm the building, hitting our concrete floor and radiating energy into the space, is actually making it in the building. So we like that. That's actually feeling pretty good in terms of what's going on. The reason that sort of works is that the sun is very low in the sky. So even if I go through and change this roof, I'm just going to pull it out here. Okay. You're still going to get a fair amount of sun penetration into the space, and that's actually what we kind of like, to bring that into the wintertime. During the summertime, however, when we go switching around there instead, oops, turn on the shadows again. We go ahead and bring this instead to like June 1st, something like that. Okay. What happens is with the overhang, the sun's actually being blocked out. So that's why we tend to do big overhangs on buildings. They do have that nice effect of allowing in the sun when we want, blocking out the sun when we don't want it. Okay? But not always do you want these gigantic overhangs. So you can take the same principle that's being applied by the overhang, and if you don't want to have a big overhang, just actually do it kind of in a much more moderated way. And that's what these shelves are about. Let's talk about it over here. So we got the shelf kind of hanging around over here. And let's go ahead and, the sun's just so high in the sky, it's hard to make any difference at all. Make it just a little bit later in the day. That's almost just too extreme, so you're not seeing anything. Because even my very puny little overhang is having the effect of blocking the sun when it's just really dead up in the sky. So let me kind of flip it over to, I'll give us a little bit of a compromise. Let's say that it's not the middle, but it's actually somewhere on the swing. What happens is you can actually use shelves to go through and block out the sun. So for example, you see a little bit of the effect of the shelf happening right in here. Let's go ahead and kind of add some more shelf elements to that, just so you can sort of get a sense of really how that works. So for example, in this specific pane, actually I can just do it for the whole roof, or the whole wall surface. Let me go ahead and see if we can grab that whole guy. Let's change it to horizontal shelves, like we put it over on the other side. Can you see what happens? Pan this. Okay. What's going to happen is these shelves are so closely spaced, they're actually sort of essentially having the same effect. They're really blocking out all the light. Okay. They're not actually blocking out the view. You still see out through the pins or the shelf just fine, but they're blocking out a lot of the light. Now, that's a little bit too extreme. Let me go and figure out really kinder spacing. Let's put them every 3 feet or something like that. Okay. Even at 3 feet, they still manage to actually block out most of the light in terms of what's happening there. You can even sort of see what's going on in terms of the shelf or the sunlight hitting the back of the shelf there. So even at 3 feet, they're actually still looking pretty good. Let me go ahead and change it back to 4 feet. Try that. Edit that type. Make them every 4 feet. Even at 4 feet, they tend to still be doing pretty good. So you don't need them every foot, stuff like that. There's really some sort of optimal angle there, and it's really based on, well, what the kind of angle of the sun is up in the sky. Let me go ahead and switch that over again to wintertime, just to show you sort of what the effect is there. If I change that back over from December to September to December, notice the dramatic effect here. We actually have, it's interesting, in December when we want the sunlight, we have this incredible amount of light flooding in, almost entirely into the space. But when we get back into anything, from like September on, or even when we get higher or back into the summertime, it's going to completely block out the light. So these shells are actually very incredibly effective about what they're doing. They really do a very good job of blocking out and kind of taking care of things without having to have huge overhangs. So you tend to see those, especially on the south side. Let's talk about why that is. So if we think about the building, and the floor and the roof that's happening up in here, okay, and we think about these shelves, whether they're on the inside or the outside, and the sun is happening up in here. Okay, what's happening is when the sun is low in the sky and it's coming in like this, it manages to penetrate. When the sun is up high in the sky, it's actually getting blocked. So the question is really, what is it that determines really what the spacing is or needs to be? And it really just has to do with really where the sun is in the sky at the different times. It's really just all that angle. And as the angle of the sun is coming down, really, what is the clipping? Because what's going to happen is on that first fin, for example, okay, the sun's going to basically be blocked out. Yeah, that's not going to hit it. When the next one comes up, well, actually, even in this one, you can sort of see. Basically, no sun's going to get in because this one's going to block the sun from hitting back in there. It's all really this issue of like how all these different little fins work together. Okay, so what is the spacing that's optimal? It really actually depends on every individual location on Earth, because for every different latitude on Earth, longitude, that's latitude, like the sun's going to be at a different height than the sky, so it's going to hit at a different angle. So you'll find that there is no single individual answer. It's really for every individual location, there's sort of an optimal like spacing for those fins to go ahead and achieve what you want to. Whether you want to have total blockage, you want to try and capture more. Yeah?
So if you're closer to the equator, can they be further apart because the angles are more extreme?
Yes.
Okay.
Yes, because it's close to the equator, the angles, it's almost always directly up in the
Yeah.
sky.
Okay.
So you very rarely have the effect. Exactly. So they
Okay.
can be much wider spaced.
Cool.
Okay. So what happens then relative to the whole notion of sun is, all this is based on the sun being relatively high in the sky. And, that kind of works out in terms of, at a high level, thinking about the south side when the sun is very high in the sky. Okay. Where it's a little bit different is when you start actually thinking about like 8 in the morning or 9 in the morning or something like that. So let's kind of switch over to there. If I go shifting this over to, say 9 in the morning, kind of rotate around a little bit. That's 9 p.m. That's not very good. The sun's really not going to be doing much for us then. What happens is in the morning, let me get to 8, get to 7 in the morning. Not only is the sun kind of coming from the east, it's also very low in the sky. So if you think about what's happening in the sun as it's moving up throughout the morning, moving from the east to the southern side, is you're not really very high in the sky, you're actually fairly low. So the angle that's hit isn't actually coming down, it's really coming at the building sideways, as opposed to coming straight up and down. So that sort of relates to why you tend to have vertical fins, because what tends to happen is, you want to sort of capture the light when it's coming straight on in there, but as the sun starts moving in the early morning, think about that. In the early morning, let's see if I can actually illustrate this and make it make sense. And I'll change this guy over here to be, our curtain system with the vertical fins. In the early morning, the fins kind of work to our advantage because when it's still relatively cool outside, we're getting the sun coming in, everything's kind of nice. It's sort of warming us up when we want that. As we start moving just a little bit later in the morning, though, what tends to happen is, let's go to 8 in the morning, 9 in the morning, 10, we even get up to 11. What tends to happen is as the sun gets higher, the day gets warmer, the fins start blocking more and more because what's happening is for the position of where the sun is, they're actually starting to hit them from the sides now, and those fins are actually blocking things out. So there really is this notion of like, the vertical versus the horizontal, which the tendency is, even if you go around this building, the south side windows all have these sort of shelves and shades. They're sort of working in that direction. Like the east and west sides actually have these very vertical things. So that's really a big part of it, is this whole notion of shading and trying to do that, trying to block that out. But let me show you one other impact that's actually kind of cool about the fins and the shading, because in terms of thinking about the sun, it isn't always shading. The sun actually has a very nice advantage that we actually like to take advantage of, and that is it's good about bringing daylighting into a space. Okay. So let me show you kind of a simple example that may start to illustrate that for you in terms of how this works. So for example, let's go ahead and I'll take this building and let me just export it, again, and using the GBXML like we have been doing in the past. And I'm going to open it up in Ecotect just so I can kind of show you something about how the sunlight works in a little more detail. That's kind of interesting. Not sure what that is. Oh, it's because my roof doesn't kind of go over, so it's I have to cap the space. Okay, let's go back to the GBXML. Okay, so I got my building, I got some vertical fins, I got some horizontal fins. Let's think about this. I'm going to go through and put that out on my desktop, just so you can sort of see another kind of analysis you could do. Let me say session 5, fins, and show you how this works. So I'm going to open up that session 5 fins, again doing my ever so annoying but effective. Opening it up in Notepad and saving it out again as UTF-8. Let's close that up and I'll bring it into Ecotect. So I'll go back into Ecotect, import it over here, desktop. Have to switch over to XML files. Okay, oops. As I look at it, it didn't grab everything I wanted to. It has all the curtain walls, but you'll notice it doesn't actually have all the fins and stuff like that I actually wanted to capture because that was part of my example to you. So let me go back over to Revit and fix that. What I have to do in Revit is actually sort of change the settings for the complexity with which it exports things. Let me show you what I mean. When I say export GBXML, I have this whole notion of, oh, simple surfaces, complex surface, that'll get you multi-pane surfaces. If you actually want to get the mullions and the shading surfaces, that's the fins and the shelves and all that kind of stuff. I need to shift over to there. Say next. I'm just going to replace that. Okay. Again, go back out, open that thing up, save that as, okay, then we'll go back into Ecotect and import that one again. So as opposed to this version, let me go ahead and re-import desktop. Okay. This one's looking a little better. It actually has fins. Let me turn on the visualization so you can actually sort of see them in terms of what's going on. And let's talk about how they're actually useful. So we have all those little fins and shading surfaces that are available to us. So what is that actually good for? It's good for, you can still with an Ecotect. Ecotect is really good. It does all the same sort of things in terms of understanding the sun, and we can say display the shadows and start to see really exactly how the building, you know, is put together. Let me kind of do a little section through the building so you can sort of see it a little bit better. That's like the section box. We can sort of see what's going on there. But here's something that Ecotect is also very good at in terms of understanding daylighting and kind of from a quality sense what's going to happen here. The idea is all these different shelves, not only shading surfaces, they can also be incredibly useful reflecting surfaces. Okay, so let me show you how that works. We can go through and in the sun settings here, actually go through and say that we actually want to see the sun rays. So we can say, show the solar rays. Oh, we need something that's called like a blocker. let's go ahead and a reflector. Let's see if I can sort of select the objects and kind of make it make sense. Go back to the 3D editor. Let me turn off those shadows for just a second because those are just going to confuse me. Let's see if I can grab this surface. Okay, if I say that big old surface there is basically a shading surface. Actually, that's, I think it will go be considered a shading surface too. Hang on. Let me go ahead and let's try this again. Solar rays. Okay, let's try this. Solar reflector. This is going to be any surface that goes ahead and reflects light. So let me see if I can do this. I'm going to try and grab the floor. Okay, I'm going to say that this is basically going to be a reflector. I'll try that now. Let me roll that around and kind of give you a better sense. These are sun rays hitting the building at a specific point in time. This is actually kind of very intense because they're basically showing up at an incredible spacing there. Let me kind of space them out. We don't need them every 3 inches. Let's just go ahead and space them every like 1 foot or something like that because that'll be a little bit better. 2 foot. 3 feet. Okay, you can start to see the rays. What you see is happening with the rays is the rays are coming into the building, okay, and they're hitting the floor. Okay, they're not actually reflecting just yet. Let me see if I can actually turn on the visualize and see if we can make it work there. So you sort of see all those rays, they're kind of hitting the building, everything's looking pretty good. But almost all of them are being blocked. There really aren't that many of them actually sort of penetrating deep inside the space. I can even say show the full rays and give me a certain number of bounces because they will hit the floor. Okay, and what's going to happen is they're going to hit the floor, then they're going to bounce back up. Okay, and then theoretically they're going to hit the floor again or hit the ceiling and bounce back in, and then they'll hit the ceiling or the floor again and they'll bounce back up. And this is how daylighting actually sort of makes it into the space. It sort of comes on down, it hits the floor, it bounces back off the ceiling, it bounces back in, and you start getting daylight back into the interior of the space that way. So this whole notion of the solar, of the bounces is actually sort of pretty interesting and good. Let's go ahead and amp it up a little bit though, because the floor is a reflecting surface, but these shelves can also be reflecting surfaces too. And that's when we start getting some really good effects. Because if we just count on the floor for being the reflecting surface, we're actually missing an opportunity to actually sort of bounce light up in different spaces. So let me change it up a little bit. We'll go back to the 3D editor and say, let me turn off all those solar rays so we're not actually looking at them. Zoom on in and say, what actually happens if we say that some of these reflectors or these fins are actually reflecting surfaces too? So what'll happen is this space and that one and this one and that one will all be reflecting surfaces too. Okay, when you do that, what ends up happening is you actually get sort of a different distribution of light. Okay. What happens is each of those different reflectors, let me go ahead and turn it back up again. Okay, basically acts as its own reflecting surface. So what happens is all the beams which hit this first reflector bounce up, and they have one path they follow through. All the beams that hit the second one actually bounce off of a different surface, and they sort of go back to a different reflection point and come back further into the surface. So each of these different shelves in turn sort of catches a new batch of beams and sends it back to a different point in light. So these shelves actually have this very nice effect is they reflect the light back in there. It starts spreading it much more evenly back through the entire space. So as you look at all these shells, what tends to happen is not only sort of are they out there providing a shading function to keep this from getting too hot in the direct sunlight, you're getting this reflecting function of bringing daylight back into the building. Okay. So as you go through and do that, as you think about these shells, like what color are those shells? What color should those shells be?
White.
It's really the most reflective color you can put on there. What tends to happen is, if you look at the shells here in our building, they tend to be, that kind of rusty red color architecturally, so they look good from the bottom. But the tops are just about as white and shiny as you can imagine, because you want to really be reflecting as much of the light back into the space as you possibly can. Okay, so they use them in that way, and it actually sort of serves a very useful function. So all along the south, you'll find that almost all the rooms are basically back in, they have these shelves on them, and they're lit up almost exclusively with daylight, as opposed to the natural lighting, which brings light back into the building, which ultimately filters into our room through all these these lucite or these polycarbonate panels to kind of bring it back in here. So very useful for bringing daylighting back in there. So think about all these surfaces not only as reflectors, but also think about them as reflecting surfaces and how they can come back in there. Now let me give you one last thing to think about as you leave, and that is as follows. And we can demonstrate this in the software, but let me go ahead and show it to you this way. I used to, because I used to design that as well, cognizant of solar energy and stuff like that, always come up with spaces that looked like this. Oh, I wanted to have some fantastic southern exposure, so I put this big old roof and a lot of glass down there. I thought that was going to be really, really very beneficial towards what I needed to do. So I do things like this. And what would happen is, okay, I go through and put something like this in here, and then you can even put a shelf in here, and then start bouncing light around. So let's think about what actually happens in this scenario. And you can actually sort of see it in the software. Okay. What happens is sunlight always bounces and reflects at the incident angle. So whatever it hits the surface with is going to bounce at that some way. So sun's coming down, it's bouncing here. Okay. The incident angle is going to come up to here. The incident angle is going to sort of be like that. The incident angle is going to be something like that. And it's really not going to get very far back into the space. Okay. Let's contrast that with a slightly different design. I'm going to put my purple.